Hi everyone, I'm Behboud Abedi and welcome to the final episode of the Basics of Rheology. Up to this point, we've covered both steady shear and oscillatory testing methods. Today, we are diving into transient tests, where we apply deformation or stress and observe how the material responds over time. These tests reveal how materials relax, recover, or permanently deform, and they are essential for understanding viscoelasticity. Let's begin with stress relaxation. In this test, we apply a sudden deformation, affects the strain, and watch how the stress decays over time. Here's a simple analogy. If I stretch a spring and hold it in place, I feel a constant force pulling back. That's pure elasticity. The stress doesn't relax. Now let's try the same thing with a syringe. When I push the plunger, that's the deformation. I feel resistant at first, but once I stop moving the plunger, the stress quickly disappears. I no longer feel any force pushing back. That's a purely viscous response. But viscoelastic materials behave somewhere in between. When you apply deformation, the stress doesn't stay constant like a spring, and it doesn't vanish instantly like a syringe. It relaxes gradually, depending on the material's internal structure. Now, let's look at creep and recovery. In this test, we apply constant stress and observe how the material deforms over time, and then see what happens when we remove the stress. Let's start with the spring again. When I apply a force to it, that's a stress. It stretches. Once I remove the force, it snaps right back. That's a purely elastic response. Now the syringe. If I apply a force to the plunger, that's the stress, and water flows out. But when I stop pushing, the plunger doesn't bounce back. That's a purely viscous response, no recovery. Again, viscoelastic materials fall in between. When you apply a stress, they deform gradually, and when you remove the stress, they partially recover, depending on how elastic they are. The more elastic the material, the more it bounces back. One great example of stress relaxation is in orthodontic braces. The wires apply a constant displacement to the teeth, but over time, the force they exert decreases. That's a stress relaxation in action. That's why orthodontists need to tighten the braces regularly. For creep and recovery, think about asphalt on a hot day. Under the weight of traffic, it slowly deforms. That's creep. When the load is removed, it may recover partially, depending on how elastic the material is. Transient tests give us a powerful way to understand how materials behave over time, not just how they flow or resist, but how they adapt, relax, and recover. And that wraps up our Basics of Rheology series. I hope these episodes have helped you build a strong foundation in my beloved field of rheology. And remember, rheology is all around us. It's vast and complex, but it's fun.